Good afternoon. Welcome to Ask the JDK Architects. We are here to answer questions. Hopefully you are here to ask questions. If not, we can all leave. This is one of the shortest slide decks I've ever created. Don't believe a word we say. Ask questions. If you're shy, or if you're out there on the internet watching the stream, you can tweet questions at me and I will select and read a limited number of them. So who wants to go first? And oh, by the way, if you're in the room, that's why we need the other microphone, sorry. If you're in the room, please come up here to ask your question, because if we repeat it, we will distort it, and that way everybody can hear what you're saying.
I like distorting the questions.
Well, you can distort it.
Okay.
No, come up here, please.
So I was just attending a meeting, a session before this one about Jigsaw, and I was wondering if I'm doing development at a client, I'm building some libraries, and you've got your access modifiers, public, private, that kind of thing. Now you've got Jigsaw coming in, and you can actually shield off, or actually just expose parts that you want other libraries to use. So if I'm just doing my own library or creating a module, why would I still want to do private stuff and not just make everything public and then shield it off via the module info?
I'm sorry, I didn't follow that.
So if I've got a library, so I'm creating a module, right?
Right.
Then I've got all the code under my own control.
Yes.
Why would I still want to make stuff private, since I can shield off parts that I don't want anybody else to use?
You're the only developer who ever works on this code? Do you trust yourself 2 years from now?
Probably not.
I mean, I don't trust myself from 2 years ago or 2 years from now. I mean, certainly if you control all the code, then yeah, maybe you don't need to do anything.
Okay.
But as soon as one more developer comes into play, whether it's somebody in your own organization or somebody maintaining some open source thing that you depend on, life gets riskier.
Okay.
I have a counter question for the room. How many people in this room as Java coders have used the private keyword to protect code from yourself?
Yeah, see, exactly.
Yeah, accessibility modifiers send a signal, right? They send a signal about whether this is, serving the code immediately adjacent to it, the code in a slightly larger circle, or the whole world. And it's hard to keep those in your head, and that's why we put them in the code.
I neglected to have us introduce ourselves, but it might be obvious. Anyway, I'm Mark Reinhold. I'll put the slide back up. And
Mark's the chief engineer. I'm the JVM architect, John Rose.
Brian Getz, language architect.
And we all work for Oracle. And for the most part, we enjoy it, believe it or not. So poll question. How many people have downloaded and played with an early access JDK 9 build? Did your existing code work? Did it break? Did it break violently? Did you figure out why? ASM? Yeah. Oh, well, they're catching up. Remy already has a build that's caught up with that. How many people have downloaded and played with a Jigsaw early access? Did your existing code break? Have you downloaded the Jigsaw EA within the last 2 weeks? Because it might be that more of your code broke. Sorry. It's shifting ground, bleeding edge. Any more questions we should ask? No, wait, we're supposed to answer them.
Yeah, we're just here to answer questions.
No, we can ask questions too. I mean, if nobody's going to ask, please come up here.
So there have been some discussions before about ahead of time compilation as a part of JLink modules and whatever. It used to be like commingled with. So what's the state there in ahead of time compilation right now?
We have a project ongoing for the last couple of years on ahead of time compilation. We're using Graal, the Graal core, which is an open source project as a base. we are able to compile ahead of time the java.base module. And you might ask, what's the benefit? And we've learned over these months a very important rule of thumb, which other people who've experimented with AOT have also found, I think. And that is that AOT gives you nearly all of its benefit in the first 100 milliseconds of program execution. So there, it turns out to be extremely difficult to find a way to beat the online JIT after that point. I think there's probably things more that we can do there, but a straightforward AOT will basically shave off approximately up to a third, maybe 10% to a third of your first 100 milliseconds of execution. And that sounds pretty pale and puny, and maybe that's why, maybe that's why Java got along without that for so long. But we think it has some particular uses for future implementations of Java where we're actually taking an old technique out of the labs of a self-bootstrapping system, implementing Java on top of Java, and there AOT is a requirement rather than a nice to have. So that's the reason we're doing AOT now, is we're looking forward to an eventual project to replace more components of the J2SE stack, the JDK stack, on using Java as an implementation language instead of C++ or assembly code.
John said J2SE. He really meant Java SE.
Yes, thank you. Sorry.
And comparing static to dynamic compilation is a lot of people assume, well, compiling it ahead of time is better because you're not doing this extra work at runtime. But in reality, like everything else, it's a trade-off. And so you're trading off compilation quality against compilation time at runtime. So dynamic compilers will always beat static compilers in terms of the quality of the code they generate because they have more information with which to make better optimization decisions. So, for a lot in previous attempts at AOT compilation, people were always disappointed that the AOT compiled code was slower than the dynamically generated code. You get to peak performance faster. And so AOT really is mostly a startup play. And for programs that run for as long as seconds, it's not actually that relevant.
And if you want to write a little program that starts up, fires off a few packets, and then shuts down, you might use other languages today for that already. But we hope eventually, as AOT becomes mature, that we will be able to write components like that in Java. And there's early indications that that's quite practical, because some of you may have seen some of the presentations by people in the labs on technologies such as the Substrate VM, which is able to shrink down a Hello World type Java program into a bundle about as small as a C program that starts up about as fast as a C program. So there is a sort of extreme amount of work that you can do in the 100 millisecond time scale, and so I think we'll get there. But we're just taking baby steps right now as far as the product is concerned. But the labs experiments look very promising, and we expect within the next year to have some open source activity along this line.
For the APIs such as unsafe that we don't want to use anymore, there's usually good replacements. For those that there aren't any replacements planned as far as like Sunmist Signal, why not just make those into APIs and bless them as being available to use? Or can we have a timescale for replacing them somehow?
So the general philosophy on this is laid out in JEP 260. We are gradually providing standard functionality for much of what's in the Sunmist packages and other unsupported things. var handles, which Paul Sandoz is sitting in the back, has been working on, handle many of those cases. But we know there are a number of critical APIs like Sunmist Unsafe that lots of people depend on, even though they're technically unsupported. So they will be there until there are replacements, and then they will stick around until at least one major release after those replacements exist. A question from Twitter, I think this is for Brian. What are the chances of JEP 286, which is local variable type inference, making it into a JVM near me soon?
What does soon mean?
Yeah, that's kind of my question.
So if that's code for JDK 9, the chances are 0. It was not ever part of the plan for 9, despite the article in the server side today, which claimed that it was, and despite the fact that we, at the keynote, said several times this was not for 9. But it's not the world's biggest feature, so using your judgment about, well, it's not for 9, but it's not huge, you can think about what the implications of that might be.
It will be in some release after, with a number greater than 9. Probably.
If you could limit your answers to the Java or Oracle business and technical space for this question, but what keeps you guys awake at night at the moment?
I'm not going to comment on any business things that might keep me awake.
Well, what keeps me coming to work, how about that, is the fact that we have an extraordinarily vibrant ecosystem that's built by and for nerds like us that runs a huge proportion of the world's computing and does so rather well and still has room for improvement, and the improvements look like they would not only be beautiful and satisfying to work with, but also incredibly productive. So what keeps me going is the next 20 years of Java.
Ditto.
Yeah, and to amplify that, I would say that the long-term roadmap of the set of sensible improvements and enhancements that we can foresee now and have a pretty good idea of how to do and are just, quote, a matter of engineering, is better than it's ever been.
This is kind of a specific question, but one of the things that slows down our vibrant Java ecosystem is a digital signature algorithm called RSA, SSA, PSS. And so in Java 8, we recently upgraded to a latest and greatest Java 8, I think update 66, decided that that needed to be validated when using TLS 1.2, and it doesn't validate. And I'm wondering if there's any plan for support for that algorithm. It's Microsoft's default PKI cert algorithm.
Oh, that's a good one.
You have stumped the panel, sir.
Whoa. Is this an algorithm for which there was already support?
No.
Support was added in this 8 update?
Well, it's kind of referred to in some of the Java documentation.
Okay.
There's an open JDK. There's a ticket for it, JDK 8146 293.
Oh yeah, that one. Yeah.
But
Why didn't you
Oh, yeah,
say
of
so?
that may not help unless somebody's Googling back there for extra information. But it was kind of not clear whether support would come in JDK 9 or ever.
Do we have anybody from the security team here? Jeanette, Sean. Yeah, you want to find Sean Mullen or Jeanette Hung can probably answer this question.
Or security dev.
Security dev at OpenJDK.
Okay, thank you.
Weirdly kind of connected, but not because of security, but because of release of features. Now we are getting Jigsaw and a more modular JDK. Is there a possibility for a more frequent release cycle of features in modules?
Fascinating question. Quite possibly. So one of the big reasons we're modularizing the platform, the JDK, is in fact to make it easier to evolve, both maintain and evolve going forward at, one might imagine, a more rapid pace. We don't foresee any time in the near future having some sort of mix and match of modules where you could take a base module from JDK 9.1 and mix it with your HTTP client module from JDK 9.4 and throw in a couple of 10 modules from JDK K10, that becomes a support nightmare. But definitely modularizing the platform, going from that bowl of spaghetti, if you've seen the ugly diagram, to the fairly sane module graph, makes for a platform that we can evolve more quickly because the components are actually identified and independent and somewhat protected from each other.
Hi, so my company, which might be emblazoned all over the back of my t-shirt, of course has a Java agent.
Yes.
Which our Java business depends on. And a reliability problem emerges because at the point in time that we transform classes, we really just want to transform bytecode, but we find ourselves tangled up in the middle of a class load because that's the way the instrumentation API is currently implemented, that we intercept the class load. There's another framework that does a similar kind of thing, but the instrumentation interface is actually hooked to the just-in-time. So it's not actually the bytecode transformation is not actually done in the middle of somebody else's class load. That's already been resolved. It's done later, just before the just-in-time actually executes.
Can you name this other framework, or is it a secret?
CLR. Yeah, and the point is they JIT everything.
Not a framework. That's an entirely different platform.
Well, okay.
Okay.
So thank you. You're right. So
I thought you meant something running on top of the JVM.
I understand. I didn't mean to. I didn't mean to be snide. In any case, it's a little simpler in some respects because they're not in the midst of a class load when they do the bytecode transformation, and so they can't get tangled up in deadlock scenarios with badly written custom class loaders and so on and so forth. And the question I have is whether there's any possibility of evolving the instrumentation API in a way that would reduce the likelihood of the kinds of very occasional, very specialized issues we see, the long tail of reliability issues.
Good question. I don't think that anybody has thought deeply about improving that API recently.
I'm thinking JLink is the answer here. That so one of the tools that comes out of JDK 9 and modularity is a link time step. So historically, you compile Java source code to Java bytecode, and then all linkage happens at runtime. And there are a lot of operations, a lot of optimizations that are sort of too early to do at compile time, and as you're pointing out, are a little bit late to be doing at runtime. And so, since Java hasn't historically had a link time, that's left you in kind of a limbo situation. So JLink is a tool that processes class files, jar files, etc., after build, but before runtime. And we use JLink to do all kinds of things, to produce custom images, to strip debug symbols out, to do bytecode optimizations, turn reflective lookup into static static references. And for the sort of bytecode instrumentation that you want to do, that seems like an ideal application of JLink, which has a plugin architecture, so you can define JLink transformations, and that way it happens once offline at build time, and then when the bytecode is loaded into the VM, it's all ready to go.
That's
a super
interesting answer.
Yes, well, there's one proviso though. JLink only works with explicit modules. If you have a pile of jar files on the class path today, I mean, you could probably apply a similar strategy and maybe rewrite them ahead of time, but JLink it can't pre-link just random jar files because it's chaos.
Right. So this approach won't apply to the mass of legacy code.
Yeah, but in 5-10 years time, it might apply to a lot of code.
So the massive legacy code runs inside a mass of recursive class loader invocations, and part of your problem is that it's legacy. But of course, part of your value add is that you work on legacy. So there's no easy answer. I will say that Java doesn't really have a just-in-time moment the way CLR does, because they have a warm-up period possibly in the interpreter. So you got to capture the bytecodes really early. But I think the right answer long term, sort of the, let's say the architectural right answer, is to do these sorts of transforms earlier rather than later, and do them in a static setting. And that's why that's one of the benefits of working with JLink and modules and even AOT and some of the other features like class data sharing. We're aiming to be able to move more of the sort of Java provisioning of application code into the before startup. And that's where we would see improvements being made rather than tweaking the instrumentation or the agent stuff to add more capabilities to do those kinds of things statically in JLink. And we're doing that even in JDK 9 now. It's a fruitful area to work in.
Great. We'll keep a close eye. Thank you.
Yeah.
Thanks.
When I say we're doing it in 9, I mean we're doing it in the implementation. For example, method handles are being spun statically where they used to be spun dynamically, things like that.
Yeah, we use JLink, of course, to build the JDK itself, so
Yeah.
it's all.
Yeah.
It does really need to work.
It works.
It does work. It's cool.
Okay, question from Twitter. We probably each have our own different answer. Biggest single Java regret?
So much to choose from.
If you go back in time, what one thing would you change?
I'm already on record with my answer, so I guess I have to say it is serialization. And not the concept of serialization, the approach to serialization, which is a magic scraping of fields that allows deserialization to bypass constructors.
The gift that keeps on giving.
So many things that could be regrets are just categorized for me as, well, that's the way it was at the time, and we found the optimal way to move through the situation and get the best available out of the opportunities. But I would say that one thing that I regret, especially this year, seeing how well Project Panama is turning out, is that when I proposed it in 2005, it was heavily vetoed by the people that were running stuff then.
Yep, that was sad.
Project Panama is really cool.
Panama's extremely cool. So Brian's regret is quite high on my list, but I would say my top regret is in 1.2 or maybe 1.3 at the latest. We should have done a module system. You know, everybody's life, both those of us who work on the JDK and everybody uses it, would be so much nicer right now, because this I don't know how many years project, I've lost count, of designing a module system that can be retrofitted onto all of the code in the JDK and the even vaster amount of code out in the world in a sensible way has been tough. It's been fun and challenging, but if we had done it earlier, it would have been better for everybody. Sir.
So the Twitter question actually trumped my question, but I've changed it a little bit. So Mark put up the Q&A slide there. I'm just saying that this is ask us anything about JDK. Is that okay?
You can
ask the JDK architect. You can ask whatever question you
cool.
want.
All right. So
we might not answer it, or you might not like the answer.
So this is the antidote of that question. So in the iPhone style, which was the best release of Java since Java?
The best release since 1.0?
Yeah. I mean, in terms of innovations and things.
I think that has an easy answer. The best release is the one we're about to ship. That's true at any given point in time.
I'm a pretty big fan of 8.
8 was very nice.
I'll do 8 too. Yeah.
As a side note, we were amazed at the adoption rate on 8. It was faster than we've seen in a long time. We also know that the adoption rate of 9 will not be that fast. That's okay. We're good with that. We've made peace with it.
There is a facility in Java in the class loader to load the class. Is there any way I can unload the class?
Yes, you can drop all references to it and to the class loader and to all objects that are instances of that class.
No, but manually I have to do it. In my applications, I have the different version of the product, so I have to spawn the new class loader with the new version of the jar. But at the same time, because memory footprint is increasing, I have to say that shut down the previous one. So how quickly I can close the URI class loader from the previous one? Will it clean the memory?
You cannot explicitly release a class, just as you cannot explicitly release an object.
Yeah, but you know, because if you were to release a class, you know, try to unload the class, and there were still instances of that class around, bad things would happen, right? So you have to make sure that no instances of that class are around, and that's the job of the garbage collector. So the garbage collector will eventually discover there are no instances of that class around, and no instances of, you know, no references to the class loader, and then the class loader will be garbage collected.
Yeah, but there is an API which you provide to do the garbage collection, right? .gc something.
Yeah, you don't ever want to call that.
No.
Okay.
Do not ever call that.
Okay.
Yeah, systemdc is one of those things that seemed like a good idea in Java 1.0, but is actually in most cases is a disaster to use, because it does a full garbage collection, which can be very time consuming when in fact you don't need to do a full garbage collection. And there are many were many instances of people doing system.gc in libraries, and this is like just a time bomb hidden in the code, and people discover years later that the source of their performance problem is that they were using this XML library that's stupidly called system.gc too often.
There is another API point, though, for releasing everything. It's called system.exit.
No.
And I'm not just joking either. That is the way to really release everything.
It's like hot upgrade we are doing, so we need to replace the old version of class with the new version of
So
the
you can't do that. You can kind of fake it out by using some of these higher level frameworks like OSGI that put, they, like everything else, you add a level of indirection. So there's sort of an abstract concept of a bundle, and if you update the bundle, then its old class loader is let go and a new one is spun up, and then other bundles will eventually refer to the new class loader, and that all works, but it's an awful lot of mechanism. If you need it, you can use it, but that's not how primitive class loaders work in the platform.
Thank you.
Sure. Let's see, Twitter. Brian, any chance of currying arguments and lambdas?
Not something we're working on right now. We have other things that we're working on right now that we think are of greater value.
Such a diplomat. Good idea or bad idea?
Well, it's just really far from the 50 most productivity-enhancing things we could be working on. So I think it's more of a philosophical request than something that really makes a difference in terms of everyday productivity. And there are just so many other things that would have more of an impact.
Yeah.
What killer API that hasn't been written yet would require currying above all else? I don't think there is one. There are killer languages that use currying, but Java has enough of its workarounds that it doesn't really need currying, apparently. In Scala, you can do nice things with currying. So maybe I'm wrong. Maybe there is a killer application from Scala, some killer API that could be moved into Java, if only we had currying.
Well, and
we don't see it.
And to take an even more obvious example, so how many people here have noticed that Java lambdas can't call themselves? I don't see every hand in the room going up.
There's two.
Yeah. So. One of the first Lambda hack days that I did, and it was with the London Jug, there were a bunch of academics showed up, and they pitched hissy fits of are you serious? You calling this a Lambda? It can't even call itself? You guys are a
fixed
joke.
Points?
And this was an engineering trade-off. We were able to simplify the semantics significantly by not having to accommodate this. And it hasn't turned out to be a big deal, right? Yes, it would be nice to be able to write factorial like you do in the computer science textbooks as a recursive lambda, but in reality, in terms of getting in the way of the everyday job of Java programmers, it's a complete non-issue. So, in a perfect world, yes, of course, we'd have all these things, but it turns out that one can get an awful lot of work done without them, and all but 2 people in the room haven't noticed. So, sometimes pragmatic trade-offs, you know, are pretty good.
What makes Java the most popular, one of the most popular language in the world?
Why is Java not the most popular language in the world?
Yes, one of, I think.
I think he's asking why is it one of?
Oh, why is it?
Because they are, no, I mean, why Java is so popular in the world?
Oh, why is it?
What
Yes.
made it successful?
Yeah, right.
What made it successful? Well, I mean, the key, the core values of the platform from the very beginning have proved very attractive to a large number of people. Readability, compatibility. Of course, I'm blanking on the other three, right? Readability, compatibility, productivity,
Performance.
Transparency. Yeah.
transparency. Compatibility is certainly a very, possibly the biggest. The fact that code from many years ago in binary form still runs. As I showed in the keynote, I took swingset2.jar from JDK 5, and it runs just fine on a Jigsaw EA build. That's a pretty powerful thing, and it's not something that you find in all platforms. In some ecosystems, like for example this one, the nature of them is such that the dominant force in the ecosystem can force people to go through phases of incompatible changes, and that actually works out. Java, the Java ecosystem doesn't work that way, so we've always tried to be very responsible about evolving it. That kind of relates to a question on Twitter. Do you think that at some point Java will break compatibility in favor of faster and easier innovation? Yes. I think we are as I see it, and I suspect my two colleagues agree, we're going through a slow phase change where we are ready to recognize that some things just don't belong there. We're ready when we need to make forward progress to remove old things. In Java SE9, we're proposing to remove, for the first time ever, we are removing 6 methods. Baby steps, but those 6 methods were preventing a clean modularization of the platform. If we kept those 6 methods, then if you wanted to use anything in the Java util package, you would all have to carry around all of Swing and AWT. That's not a good solution. And it turned, and we were careful about this. We studied like all the jars we could find on Maven Central and elsewhere, and found that these methods were actually very rarely used. So, low risk thing, but we've been very clear about it. We gave notice when Java SE8 shipped that these 6 methods are history. We've removed a few other mechanisms in JDK 9 that were either standard and rarely used, or non-standard and rarely used, and these are all documented in the various JEPs. And of course, in 9 we're also encapsulating most JDK internal APIs. Now, from a purist standpoint, that is not an incompatibility, because after all, you should only be using the standard APIs, right? And nobody here uses non-standard APIs, right? Oh, sorry. So it is a practical incompatibility, but we've tried hard to communicate all that and provide tools to help people move beyond it and explain the reasons for it, because we know that in some cases it will be painful. And further down the road, I can imagine entire subsystems perhaps being jettisoned from Java SE. Do we really need to carry around JAX-WS and JAX-B and Corba? Very useful to some people, but do they actually have to be part of SE? Maybe not. So you guys wanted to riff on compatibility?
Well, I want to go back to the previous question for a second, and then I'll riff on compatibility. So I think one of the fundamental things that's made Java so successful is its commitment to unobtrusive safety. Right, so if you compare Java to what was around before then, which was mostly C, there were a lot of aspects where you had to manage safety yourself. You had to manage pointer safety, you had to manage type safety, you had to manage memory safety, and Java managed to take these responsibilities away from the program in a way where you didn't really miss them. and you had the runtime, doing garbage collection for you. You had, a somewhat stronger type system, which got stronger, further over time. You can't munge a pointer into an int. The platform keeps you from doing that. So there are entire categories of bugs that you just can't make in Java. And if you're not wasting energy avoiding or chasing down those bugs, you can focus that energy on more valuable activities. And I think having found that balance of unobtrusive safety, I think, was kind of the secret sauce. And there, like any other success, there was also a little bit of luck. It was the right thing at the right time. And
let me add another secret sauce. The thing that I have come to value even more over the years is the quality of the original specifications, which has been maintained. But if you look at the Java language spec, you learn to lean on it and to implement it and look for all the corner cases and how they're documented. It is, I think it's maybe the best programming language spec ever written. It certainly is it's in the top 10, got to be.
It's in the top 5.
Yeah, and you look at the authors, Gosling, Steele, Joy, they put in a lot of time and effort into doing it, and it's been a gift to millions of people.
Their successors have carried the torch well.
Yes, they have awesomely carried the torch. We wish Alex was here. He's one of the successors, but he's next door talking about modules. And likewise with the JVM specification, which was started by Tim Lindholm. Beautiful work and work that was not perfect. Nothing's ever quite perfect, but was very strong as a foundation for building something that would be compatible. Something so compatible that you could do clean room implementations of it. IBM has made a business, and Oracle made a business, aside from Hotspot, with JRocket, doing a clean room implementation based on the specs. It's very difficult to find a similar success for a specification like that.
Mike?
So at the session a couple of years ago, one of the questions that got a lot of interest was the prospect of using UTF-8 as the default platform encoding. Is there any progress on that, or new obstacles that you found in moving towards that glorious future?
Thank you for the reminder. I'm not sure anybody's. Yeah, no. I'm extremely sympathetic. I don't think anybody has looked at that recently. One could say that if we're going to do that, 9's the release to do it, because we're breaking everything else anyway, right? Yeah. Thanks for the reminder. I'll ask.
The amount of UTF-8 text in the world is just increasing, particularly with emojis, and the default platform encodings, particularly on Windows or the 8851, just aren't the right choice, because UTF-8 text is almost all of the text that's in the world now.
Yeah. No. I mean, hey, I'm NUS UTF-8 all the time.
How many people in this room consciously avoid UTF-8 as a platform encoding when they launch Java? Waiting.
Crickets.
0. All right, well, that's a data point.
Yep. Sure.
Can I ask 2 questions?
You can ask one question.
One question, okay.
Then you can get back in line.
Yeah, okay. So how do you stay current with technology or continue learning, or like what do you do to do that?
It's overwhelming. Talk to as many people as we can who are not involved in our own little bubble ecosystem, read everything we can, watch conference videos. There's a lot of information to process, but you just have to decide to be open to it, because it's so easy to focus on that which you're an expert in and miss everything that's going on outside. And so you really have to make a conscious effort to broaden your input sources and make time for them.
At multiple scales. Yeah. So learn what your colleagues are doing down the hallway. Learn what your colleagues across the ecosystem are doing. Learn what competitors are doing. Make friends with your competitors. And then learn what people that you don't normally cross paths with are doing. And then, since we are in computing, go read some math and some science. And so this year I read a couple books by Raymond Smullyan on mathematical logic. Just a brilliant refresh on that stuff that gave me fresh, fresh eyes for what I do. So it works at multiple scales.
Yeah, I often, I make a regular point of trying to keep up with the programming language academic research. That's kind of where I came from. It's hard. There's an awful lot to read. There's an awful lot of it that I just don't understand anymore. But it's out there. And another thing I found helpful is I occasionally go back and reread papers that I read 30 years ago to sort of get re-inspired by whatever beauty and clarity I found at that time. I think probably every 5 or 6 years I go back and read the Steele and Sussman Lambda papers. They're just key, golden keys to so many things.
Yeah.
What are the chances of type inference for local method return values, and maybe for relieving us from the semicolon?
That's 2 questions. So you'll have to go back to the end of the line for the second question. Type inference for method return values is extremely unlikely, and the reason for that is, with the exception of private methods, methods are part of your API, and there's a binary compatibility consideration. You don't want the return type to subtly change just because you changed the body of your implementation, and now all of a sudden your program no longer links because some other client that called your method thought the return type was this, embeds that signature in the class file, and now the signature has changed. Arguably, that's not an issue for private methods, but that means that then refactoring a method from private to non-private, is a less easy refactoring. The short answer is never going to happen, for philosophical reasons. And the semicolons, I'll be serious.
That's both the short and the long answer.
The list of things that are more important to work on than that is virtually infinite.
There is a field where colon relief is important, but it's medical.
So, given your greatest regrets and the likelihood that Java could break compatibility of things, could we ever see a new serialization mechanism and a removal of the current joyful serialization, which,
It's certainly quite possible that serialization could improve. It seems unlikely that we could fully get rid of the existing serialization mechanism, because there are situations that basically won't serialize under anything but the current situation. So we can't necessarily take away the existing mechanism if we can't replace it with something that is, compatible across the board. That said, we've been making, a certain amount of progress in identifying a serialization mechanism that is safer, easier to reason about, results in smaller object streams to which code could migrate. And we think that's probably about the best we could do, but it's definitely something we want to do.
I'll be more aggressive than that. I want to take it out and shoot it one day. Once we've had a viable replacement for 98% of the use cases, it's just the number of security vulnerabilities we have had to fix because of that mechanism is just too painful.
If you look at serialization, what it really amounts to is a secret, contorted way of adding new constructors to classes, sometimes undeclared, and that just doesn't work very well with any other part of Java's workflow. So what we need is some way of declaring constructors in a much more disciplined and reviewable, auditable way. And then for the other end of the equation, co-constructors that can take apart an object into the operands to the constructors. And so that there's ways to do this, and the way we have now is incredibly contorted and low level and impossible to understand. But you know, everybody who's tried to do this knows that, of course, they want to be able to take an object apart into its contents and then put it back together. But that's a handshake and a process that the author of the class needs more control over, or there's never going to be any security.
Yeah, I'd like to remind everyone that one other reason why Java is so insanely popular has always been the very high quality of its libraries. From the very beginning, when I came to Java as an application programmer, and that was one of the things that drew me, and that's still what draws people from other languages, where it's often very difficult to find a deep set of standard libraries, such as in C++, for example, or where there are so many libraries to choose from, all of varying quality of implementation, and languages that should rename unnamed, such as JavaScript, where this is something that Java really excels in. So I wanted to bring up that UTF-8 remark that came and turn that a little bit to java.lang.string. Nowadays, java.lang.string, as of Java 9, is no longer a sequence of 16-bit car values internally. The library, however, still exposes this fiction, and it is super inconvenient for developers who more and more run into characters that require two 16-bit car values to be represented. The only thing that one can do right now is you can turn a string into a stream of the Unicode code points, which is nice. It would be nicer if one could also easily put it back. It's not pretty right now. It would be even nicer if the API was cleaned up to present a string as a sequence of what it actually is. Is that something that someone is looking at?
So going back to that regrets question, using UTF-16, UCS2 as the native encoding, it's in my top 10. I don't think it's in my top 5, but it's definitely one of those things where, you know, it was actually a controversial decision at the time. It was seen as very forward-looking, and yeah, 16 bits, that's going to be plenty, right? We've heard that before in so many other dimensions.
Emoji.
Yeah.
640K.
I don't know. Introducing another string abstraction, I've seen this happen in other languages, and it's extraordinarily painful. I think in Haskell there are two or three different string types that are commonly used, and Python has always had this weird distinction between strings and sequences of characters. I'd love to see a better string abstraction that internally allowed UTF-8 that provided you the ability to do arbitrary indexing, but in some cases maybe made it a log cost rather than a constant cost.
That's what you have now.
No, it's not actually. Well, for modulo code points, but anyway,
code points are there.
Yeah.
Code points are there.
If Java ever had value types, then there could be a value type for code point.
If hypothetically speaking it ever had value types.
Which would be the basis for additions to the string API that would be more convenient for programmers to use without the cost of boxing.
Yeah.
I think that's a good
So in that hypothetical future, things might be better.
Yes. That would be a good timeline.
Till then?
Part of the problem is that we ask that people use the indexed char at accessor to pull stuff out of a string, and that so strings are treated like arrays, but strings are really concatenatable, logically concatenatable symbol sequences, and so if you're willing to back off and treat them as streams like you observed, then you have a more natural way of getting code points out of them. But as long as we supply classic C-style for loops and iteration that uses I and I++ and get element at I, there's going to be a severe performance problem with allowing strings to contain anything other than a fixed size element. So we're moving away from the old for loop, but it still tends to hold us back on the decisions we can make about data structures, especially the one that's at the center, like string. Any data structure at the center of everything, like string or array, it's very hard to evolve that.
What's your opinion on Spring Framework, and in particular, do you feel like it's not needed because Java can do all of that already, or do you feel like it's a good way to simplify things and kind of improve the Java language?
Which framework?
Spring.
Oh, Spring.
It's a framework. Some people find it useful. Brian, I think you know more about it than.
Yeah, I mean, I think application level frameworks work at a very different level than the language does, right? So our job as language and platform designers is to provide the sensible set of primitives and programming model in which you can express the things that you want to express, both applications and frameworks. But frameworks, the role of frameworks is to abstract out common application tasks, to eliminate redundancy and improve reliability in applications, and that's a perfectly sensible thing to do up at that level. But down at our level, that's it's all just application up there from our perspective.
It's really important, but from where we sit, whether it's Spring, Java EEs, Tommy, whatever, it's stuff up there, and then we have to make it work well. But
sometimes you have to put in hooks to make frameworks work well. In other words, a framework can be at first written on top of Java unmodified, but once in a while you find places where, like maybe hooks for hibernation or something like that. Yeah. At that point, what needs to happen is that the framework people need to engage us and say, if you were able to give us these hooks here, then we could make our lives together much better.
As indeed they have.
And they do that all
many
the time.
times over the years.
Yeah.
So, and a sort of a forward-looking example of that would be, we want to be able to code without what I call so many dinosaur threads in our applications. We want a reactive programming model where there's events that trigger other events, and you don't have to have a multi-megabyte thread pulled along behind you. And so, in order to do that, you can use Java threads to emulate actors and reaction points. But they have costs, and so maybe there's some things that we can do in Java in the future which would allow reactive frameworks to run more efficiently on top of Java. So there are I would say there are lots of potential cut points down into the system which we need to develop alongside our friends that are building on top.
I'd like to ask you personally what IDE tool editors you use for editing Java and why you choose those.
So I'm a big IntelliJ fan. I've been using IntelliJ since version 2 of their product, which is probably like 16, 17 years ago or so at this point. It's by far the best Java IDE. I mean, I tried them all, including many of them that are out of business, and there's no comparison.
In order, Emacs, IntelliJ, and NetBeans. And if you want the bits right there in your fingers, and you want to be able to write macros that work on the bits, then Emacs is your friend. It's the hacker's multi-tool.
Yep, Emacs. It's wired into my fingers. I've been using it since sometime in the late 1970s. Occasionally NetBeans if I need to, make a GUI or something, but that in my line of work, that's pretty rare. So.
Any chance to see in the future shorter release cycles or minors and majors or something that do result in more agility? Or
sure, there's a chance. That's actually an interesting question. So we spend a lot of time thinking about how long the release cycle is, ought to be. We look historically at how long has it been in the past, and of course it's been highly variable, sometimes for problems that are not engineering problems at all, but corporations merging and stuff like that. What is the optimal cycle? I think something that we definitely want to look at, especially given the experience of 9 being this feature-driven release, is would the platform, would the wider community be best served by a more rapid release cycle that had a strict, a really strict train model, which was just, okay, every year we're going to ship at this time. If your feature is ready, 6, 7 months before, then you go in, and if it's not ready, then you just wait. So that's something we've already done some thinking about. Will we switch to it? I have no idea. I'd be curious to know how. It's always been our sense that a yearly cadence would be too fast for a fair number of users in the ecosystem. Lots of we hear both directly and anecdotally. Lots of companies, they only they've got big deployments. They only want to have to test and qualify everything once every 2 or 3 years. So if you were going to ship a new version of Java SE every year, they would just skip versions, and that would be bad. And so I don't know. So I mean, how many people would like a yearly cadence, strict train model, like Eclipse and a number of other projects do?
6, 7.
How many people prefer a feature-driven model where there are one or maybe a handful of big features and the feature doesn't ship until those are done? Interesting data.
More than 50%.
Interesting data. Thank you. I will not predict the future.
What are the top things you'd want to remove from Java, like your top thing?
Mark already named his.
Yeah, I think we already answered that question. Biggest regret.
I meant for each of you. I wasn't saying
Oh.
just like, I don't know, maybe like, do you think about like null, maybe make it so that
I would like to, we are so concerned with compatibility because we don't want to break trust with the whole ecosystem, right? So removing stuff is really difficult. So if you ask, what do we want to remove, that's like an idle dream. But there are things we want to supplant. There are items which we want people to stop using so much and use better things. Serialization has been mentioned already. I would say, I mentioned the old-fashioned for loop. I'd like to see less use of that. I can't remove it, but I'd like to see it streams or the new style for loop or a new for loop that sort of is stream-like. That would be better. That would be something I'd like to use to supplant the old for loop. And even more important, but in a similar vein, another killer of program abstraction and parallelizability is mutability. Mutability by default, I would like to perhaps not remove, but supplant. Make it easier for programmers to work with immutable, non-mutable, persistent, constant data structures, and have that be the notational sweet spot rather than currently, which is everything's mutable and everything has a race condition in it.
I'll second that one. I think Clojure has found a really nice balance between mutable and immutable.
Yep.
They're definitely good ideas to be studied there.
Mutability is the exception.
You should have to pay for every use of the assignment operator, and the price goes up with every version.
Yeah.
Hey, revenue opportunity.
Yeah. New business model.
Revenue. Oh, yeah.
So Jigsaw, we know, I'm sure you guys knew at the very beginning it was going to be very difficult to pull off, and it's been proven by how long it's taken.
It turned out to be even harder.
As you dug in, were there things that you were like, how the hell did that even work? I mean, as you tried to dig in, even with all the preparation, were there things that just totally surprised you that were in the product as you tried to?
Do you mean things inside the JDK?
Yeah.
Yeah, some of the cross connections, like those 6 methods that we're removing in 9. So I actually have a bit of fun here. So John, why did the PAC 200 API need event listeners?
Because of progress bars. I apologize.
Seemed like a good idea at the time. That's a legitimate reason, but amongst the methods we removed were the event listener methods on PAC 200. Sorry. Sorry, they're gone. Yeah, I mean, there were lots of surprising things. On the plus side, there was fortunately a fair amount of informal discipline over the years. Even going back to the very beginning, to try to keep things clean, to try not to have gratuitous dependencies. I mean, sure, we found stuff where, you know, some code in the core implementation was reaching into the guts of the XML parser, and like, oh, really? But I remember back in the day, you know, working on 1.1 with the first release I worked on, and I happened to notice that, you know, a well-meaning engineer in the AWT team had put some get icon methods into Java Lang system, which, you know, seems like a good idea. I mean, you know, you might want methods in the system to get icons for the running Java program or whatever. And I went and asked Timmy Lindholm about it, and he said, "What?" Because it was just an obvious, you know, even though we didn't have modules, it was just an obvious violation of what informal subsystems we had. And so, you know, I'm grateful we had at least the informal discipline over the years, so that it wasn't so painful.
So that only took like 5 years to detangle the JDK.
More than that. We started in 2008. Yeah. It's 5:30. Last question.
Any chance to bring features from like Project Lombok into the JDK, or any plan to reduce the amount of boilerplate in the language?
I believe there would be zero chance of features specifically from Project Lombok coming into the JDK. Brian, would you agree with that?
Somebody missed the keynote. So at the keynote on Sunday, we did talk about boilerplate reduction features. They were not specifically Project Lombok. But we do care a lot about boilerplate, and we do have, you know, a number of features on deck for eliminating everyday boilerplate. We showed local variable type inference. We showed the ability of the compiler to generate default constructor equals hash code two-string, you know, type operations. So so yes, but you know, exactly what those features are, when they are, what version they come in, to be determined.
And maybe they make it easier to program without mutability.
Indeed.
Okay, one last item. This just in from Sean Mullen, our security lead, the Microsoft RSA SSA ... issue is known. 4 other people have reported it. We will look into it after Java 1. All right, with that, thank you very much.
Thanks.